All right, so let's get to the types of chemical reactions that you're going to see come up quite a bit in your GChem career. The first of these we're going to look at are what are called neutralization reactions. And this is a type of an acid-base reaction that forms a salt, which is any ionic compound. We just use that term salt. Doesn't necessarily mean table salt. It could, but salt is more of a generic term for an ionic compound. But it forms a salt and water. So let's look at an example of this. Let's take hydrochloric acid, which is a strong acid, react it with sodium hydroxide, which is a strong base. And these two substances will essentially, if you have equal amounts, equal moles, they will neutralize each other to form sodium chloride, which is our salt. It's an ionic compound, and water. And so it's kind of interesting to see here how we take two really dangerous substances. If you have hydrochloric acid is a strong acid. It's a potentially very hazardous substance. And same thing with sodium hydroxide. Bases are just as potentially dangerous as acids are. But we take these two very potentially dangerous substances and mix them together, and we get something that's fairly innocuous. That's the word I was looking for. Um, like sodium chloride. I mean, obviously, if you put a little too much salt in your diet, that's kind of not good. But um, and water. So that's kind of the interesting to see with these neutralization reactions. And let's take a closer look at the net ionic equation for this. Sorry, I'm having technical difficulties right now. There. Okay, I think I'm better now. All right, so we're going to draw the complete ionic equation first, and then we'll start canceling out the spectator ions. So anything that's aqueous, we're going to break apart. So that's HCl, and then sodium hydroxide, we're going to break apart. And then the sodium chloride, we're going to break apart. But the water, since that is not aqueous, that is in the liquid form, we will not break that apart. And then let's just start canceling some things out. So chloride's on both sides, sodium's on both sides. And now when we draw whatever is left, our net ionic equation is just H plus OH minus makes water. All right, so let's take a look at this example. What we're going to do is draw the reaction that is being described here. So we have a solution of barium hydroxide is neutralized by a solution of nitric acid. Now you'll notice that this statement does not say what the products are. And it's assuming that you know in a neutralization reaction, your products should be a salt, an ionic compound, and water. So let's just work on drawing our reactants first. So barium hydroxide, barium, remember that's a +2 metal, hydroxide's -1. So this will be our formula for barium hydroxide. And it's neutralized by a solution of nitric acid. Hopefully you have that, you know that, what that formula is. Okay, so what is my salt going to be? Well, I'm going to take the barium cation and I'm going to take the nitrate anion and put them together. And that's going to make water as well. So if we try to do a quick balance, We'll just fix the nitrates there. This will fix the number of hydrogens. And let's do one kind of final check, because you'll notice I haven't put anything next to the barium nitrate, like what state is it in. So this is where you need to look at your solubility table. Okay, you'll see all the nitrates are soluble. So we know that that salt is going to be aqueous. Now let's draw a net ionic equation for this. So we're going to break everything up into its ions. So we'll have barium ions, we'll have two hydroxide ions. Why do I have two? Because that subscript of 2 means there's two hydroxides in barium hydroxide. And then I'm going to break up nitric acid. So I keep the coefficient. I use the coefficient for both ions of nitric acid. And then come over to barium nitrate. So barium plus 2. Again, two nitrates, since the formula says I have two of them. And then water. I'm not breaking up water into any ions. And I'm going to cross out what I see is the same. So on the left, there's barium. On the right, there's barium. On the left, there's nitrate and nitrate on the right. And I'm just going to draw what I have left. 2OH minus plus 2H plus makes 2 waters. So remember what we had said, one of our ground rules for balancing equations was that all of the coefficients had to be in the lowest terms. So since each of them has a coefficient of 2, I divide all of them by 2, and that gets me to a properly balanced net ionic equation. Now, another common type of reaction we're going to look at are what we call gas evolution or gas forming reactions. And as the name implies, these are just reactions that form a gas. A gas is one of the products. Often this is an acid-base reaction or a redox reaction, which I'll talk about in another video. But let's kind of look at one of the most, prevalent and fun gas-forming reactions that you probably have had experience with. So you probably at some point in time took vinegar, which contains acetic acid, and reacted it with baking soda, which is sodium bicarbonate. So vinegar, baking soda, make a volcano out of it. It produces a salt, in this case, what's called sodium acetate. And initially, a substance known as carbonic acid. Carbonic acid is not very stable at all. In solution, it immediately breaks down into water and carbon dioxide. And that's the gas that you see coming out and forming all of those bubbles and causing things to spill over when you make your volcano.